Hello and a very warm welcome to this webinar hosted by Delta Energy and Environment. Today we'll be talking about the new energy transition and what this might mean for stationary power gas engines. We are delighted to have so many people registered and attending the webinar today. I see that there are a few folks still dialing in, but since it's just gone past the hour, I think we will make a start. So first of all, let me introduce you to my two colleagues that are joining me today. That's Dina Darshini and Silvestros Vlachopoulos.
Hi, everyone.
Hi, hello.
And my name is John Murray. Both Dina, Silvestros and we all work within the distributed power team here at Delta. This team looks across global markets for distributed power, providing detailed market sizing statistics, forecasts, and insights on the market drivers for distributed power. Before we get started properly, some brief housekeeping. We will present this webinar for about 20 to 25 minutes, and we will have time, about 5 to 10 minutes at the end, to take questions. Throughout the webinar, there is the opportunity to ask us any questions you might have. So hopefully you will see on the right-hand side of your screen a box, as shown on the slide, which you can use to submit your questions throughout the webinar. The webinar is being recorded, hopefully, so there will be the opportunity to watch the webinar back at your leisure afterwards or forward the webinar onto your colleagues. You will also be emailed the link to the recording once it's published, hopefully later on today. So the agenda for today, the core of today's webinar will be focusing on the emerging opportunities for gas engines within new energy. We will then discuss how some of the major gas engine OEMs have been pivoting their strategy in a bid to grow their business within this new energy space. Towards the end of the webinar, we will conduct a poll to gather the opinions of everybody that's on the webinar this afternoon. And we'll be discussing briefly the Delta Distributed Power Service. And like I mentioned at the end, we'll have time for Q&A. So I'm aware that there are a few people on the webinar today who are maybe not so familiar with Delta and what we do. So allow me to give a very brief introduction. Delta exists to help our clients navigate the transformation of the energy system from old energy to new energy. And we provide advisory services to help our clients succeed in this transition. What do we mean by old energy and new energy? So, in the past, energy generation was centralized, generally carbon intensive, involving the sale of kilowatt hours and with very little engagement really with the end customer. Today, as I'm sure most of you are aware, the energy system is changing to one which is much more distributed, low carbon, and where the value is much more centered around offering customer-centric services and solutions. In other words, the energy system value is heading more downstream. And Delta, we as a business, our sole focus is on this new energy space. And on this slide here are just a few of our past and existing clients that we have helped with on this journey towards new energy. And if you'd like to learn more about how we help our clients, how we support our clients, please do get in touch after the webinar. So without further ado, I'm going to hand over to my colleague Silvestros, who will discuss some of the emerging opportunities that we are seeing for gas engines within this new energy sector. So Silvestros.
Thank you, John. I'll start with this slide by presenting the new opportunities for gas engines, as you mentioned, in the new energy space. So first of all, let's look at some major disruptions and what opportunities they can bring for gas engines. First of all, the first trend is that the amount of renewable energy in the electric grid is increasing steadily globally. As a result, there are rising concerns about electricity price volatility and unstable grids. These factors create opportunity in the following applications. So starting with flexible generation, let me just stop here to clarify this a little bit. For these applications, we consider sales of engines that are operating flexibly to balance the grid or installed in peaking power plants. And for further context, let me explain what we mean by operating flexibly. Traditionally, gas engines have been used with a utilization factor of more than 90%. By flexible operation, we mean a utilization factor that is less than this amount. Next on, we have microgrids and hybrids. So by hybrids, we consider applications where gas engines are deployed in a hybridized plant, meaning a single unit that combines gas generation with either storage or renewable energy generation. Another disruption is the shift to lower carbon generation. And when comparing natural gas with other fossil fuels, it is less emission heavy. Therefore, another opportunity that emerges for gas engines is diesel replacement. Finally, a more general trend is that over the last decades, there is a global push towards digitalization. The implication is that data center capacity is growing very rapidly. And the question here is, what role can gas engines play within the data centers? In the next few slides following this, I'm going to discuss all of these applications and the challenges that gas engines have to face in order to succeed. Starting with flexible generation, first of all, it is a promising application for gas engines because flexible operation is one of their key advantages as a technology. But let's look what are the key market drivers that you expect to see in markets with activities in this application. First of all, an existing policy framework supporting flexibility helps boost sales. By policy framework, I mean things such as the capacity market or ancillary services. Then we have increased renewable energy penetration in the electric grid and growing energy demand that creates a need for new installed capacity. Now, let me bring some market examples for this. If we combine the first two drivers, this leads to a sort of recurring sales market. By this, I mean a market where we have year-on-year sales. An example of such a market is the UK. And typically, these market sales would be across a wide range of engine sales. Now, if we combine the two last drivers, it leads to one-off sales market. By one-off, we mean cases where you basically have one power plant built every 2 or 3 years. These have a more random nature in general and typically use larger gas engines. This could arguably be many countries across the globe, so I can't really give an example such as the UK. But for example, from Latin American countries to even China in the future. Now, it is important to highlight at this point that gas engines are facing competition from alternatives, and this is a key challenge for this market. Whereas some of these alternatives that you see here, such as flexible hydro and interconnections, are very well established alternatives. The real threat for gas engines comes from the sort of emerging alternatives, such as batteries, demand-side response, or better forecasting capabilities for the intermittent generation from renewables. We see these things more as a long-term threat, so looking more at a time frame of longer than 5 to 10 years. But their threat is increasing every year. Next on is microgrids and hybrids. So because of the similarities of these two applications, we have decided to group them together for this presentation. Let's start by what we consider a typical role of a gas engine in a microgrid. Most commonly, you will find the gas engines in CHP mode. The idea here is for them to provide heat for the system and at the same time some electrical flexibility. In principle, they can also be used in power-only mode. So if there is no need for a heat source, then they can just provide electricity to supplement the system. And this brings us to the major challenges in this application. So first of all, infrastructure is a major challenge, and this is because microgrids can be a very good alternative in remote areas without an electric grid, but this is where you wouldn't typically expect to have a gas supply. Then again, thinking of these remote areas, the capex cost of such a solution can be quite high in comparison to others, and this is also a major barrier. Finally, it is important here for me to underline that although we have seen many examples out there in the market of gas engines being used within a microgrid, the market presence does not always translate into new sales. We have seen many examples where projects are being built around existing CHP systems, for example, within university campuses, with the real new add-on on these systems being the renewable energy supply or battery storage. So what drives these markets anyway? I'll discuss this through the example of the market leader for microgrids. US is the market leader, and there the market is driven by grid resiliency concerns and growing peak demand charges. Next on, we have diesel replacement. Here the opportunity comes from gas engines being less CO2 intensive alternative. In order to discuss this market, we're going to first consider the two different ways a diesel engine can operate. So first of all, if you consider diesel engines in continuous operation, this is a space where gas engines can easily displace diesel engines, of course, assuming that there is an available gas supply, due to the OPEX costs involved with gas gensets operation. An example country where this is taking place as we speak is Indonesia. Now, on the other hand, if we think of a non-continuous operation for diesel gensets, there are many key challenges for gas engines. So, first of all, we have fuel availability. Diesel is easily stored and easily available when need be. Moreover, backup generation is a capex-driven application, and diesel engines have lower installation cost. And finally, despite improvements in gas engine startup capability over the last few years, diesel engines still have the edge here. So, coming to the question, which market to watch for diesel replacement? This is an example from our latest distributed power report, and it shows some stats for the US market. When looking at gas engine sales at sizes where you would typically have standby generators, this is between 0.4 megawatts and 2 megawatts, and this is also for 2017. Our statistics show that around 40% of them were engines in non-continuous power-only mode, which shows a key trend for the US market. And our final focus for today is discussing the opportunity of gas engines in data centers. This has drawn attention because data centers are major energy consumers and are expected to grow even more significantly in the future. So to prove that, this is a graph from Cisco Global Cloud Index, and it shows how fast hyperscale data centers are forecasted to grow in the future. And because of these expected growth and the current levels of energy consumption, there is ongoing pressure to data centers to reduce their carbon footprint and increase their energy efficiency. So how can gas engines help with this goal? First of all, let's see the potential role for a gas engine in a data center. So data centers need, first of all, continuous power, then continuous cooling, and they also need backup power to make sure that they operate 24/7. And whenever you hear continuous need for power and heat, this brings in mind an application like trijet generation. And this is indeed where we have seen some activities across the countries that we're looking at. The only issue here is that you also have heat production, so you kind of need to have a heating load for that heat production, which is why we have seen sales in applications such as commercial buildings that also have a data center close by. Now, looking at the potential role as backup power generators, here the challenges are very similar to what we have discussed for diesel replacement. And one potential way that gas engines can play a role could be with a storage and engine hybrid solution, where the storage basically takes up generation for the first few seconds until the engines start production. This brings us to this slide where I'm going to summarize some of our findings from our applications report. So this map shows our thoughts for the potential of these applications in some major gas engine markets. We have US, UK, Germany, Japan, and China. USA presents opportunities across all of these applications that we have discussed today. For UK and Germany, we see flexible generation, data centers, and diesel replacement as an interesting opportunity. Whereas for the Far East, we see microgrids, data centers, and peaking and flexibility as an opportunity. And now I need to underline here that this is just a snapshot from our recent report, which covers 20 different countries. And my colleague Dina is going to discuss this more thoroughly in a few seconds. So I'm going to pass on to Dina now.
Yeah, thanks, Silvestros. So, all these emerging applications discussed by Silvestros present new opportunities for gas engine players. But capturing sizable market shares in these markets mean that manufacturers may have to move away from a business as usual approach. So we show some examples here. So for example, MAN Diesel and Turbo, who's a manufacturer of reciprocating engines, gas turbines, and steam turbines as well, has rebranded to MAN Energy Solutions in alignment with its product portfolio expansion to include hybrid, storage, and digital service technologies. And they also believe that there's growth potential in power-to-gas technology, which allows electricity generated from renewable sources to be converted into a gas fuel. Then there's Rolls-Royce Power Systems, which has the Bergen engines and the MTU-branded diesel and gas gensets within its product portfolio. Now they're investing in a startup company called Quinis, a provider of innovative energy storage and control systems. And they're also adding turnkey microgrids to their portfolio. Then we have companies like Wärtsilä. They have a cooperation with Schneider Electric to provide solutions to hyperscale data centers. Wärtsilä has also introduced sort of like a package hybrid solutions which integrate engines, solar PV, energy storage, and energy management software. Incidentally, actually, Wärtsilä, through its acquisition of Greensmith Energy, which is a grid-scale energy storage solutions provider, also has a partnership with Hyundai, a South Korean auto manufacturer, to develop second life battery products. Then at the bottom, you have the new GE Distributed Power. That's their new logo. So Advent International's 3.3 billion purchase of GE's distributed power assets was completed last week. Just scanning through press releases and seeing interviews. So the company is now called INEO, which is described as a standalone business with a focus on distribution and digitalization. Now, INEO is seeking to ride the massive energy sector transformation and megatrends like decentralization, increased renewables and intermittency, and diesel substitution. They've also mentioned that they could be exploring renewable production of hydrogen that could be mixed with natural gas to power its engines. So, overall, there is evidence showing that distributed power OEMs believe that to make it in the era of new energy, they will have to expand their product portfolios or form strategic partnerships or offer energy solutions and services. And Delta EE will definitely be monitoring industry and market developments on this front. So all the findings discussed so far today in this webinar comes from our distributed power service. Now, at the end of 2018, we would have produced a range of in-depth gas engine market reports looking at from, for example, Argentina, Australia, all the way to UK, USA. And the reason we've chosen these countries is a mixture of it, including some countries which are already healthy, matured markets, some countries showing tons of growth potential in the future, or countries where our subscribers are already active in or planning to enter. So these countries alone, in front of you in the screen, account for more than 80% of the global market for stationary gas engines. We also have regional reports looking into the dual fuel engine market, as we see this, especially in the two regions in your slide. So together, everything on this slide covers over 200 pages worth of comprehensive market analysis. And in addition to that, so in Q1 of 2019, so next year, in a few months' time actually, so Delta will publish its Global Distributed Power Market Report, which will provide insight on the regional interplay between various technologies. So you got your gas, your diesel, your oil, and dual fuel engines, the gas turbines, solar PV, wind turbines, and energy storage. So what is actually evident even now is that competition is intensifying as each of these technologies encroach into each other's space. So you have some gas engines stealing market shares from gas turbines, or models of gas engines starting to match diesel gensets' quick startup times. So there are, many trends already evident. There is also the growth in some of these technologies may, as we discussed earlier on, inevitably create opportunities for other technologies. So either as a hybrid or packaged solutions. And this report would aim to discuss all of this. Also available is the applications report and the findings of which we've discussed briefly here today. But the report itself actually will include more granular data breakdown. So all reports in this and the previous slides are available for individual purchase as a standalone report. So hopefully that gives a flavor for the distributed power service. And I'll pass on to John Murray, my colleague, now to get on to the exciting poll.
Yeah, thanks very much, Tina. So that's, and Silvestros, I think that's a good summary of some of the activities that we've been conducting within our distributed power team over the last few months. And I think really the emergence of new applications is something which a lot of our subscribers are asking us questions about as they're trying to kind of develop new products and services within this new energy space. So during the webinar, Silvestros talked us through some of the emerging applications that we are seeing. So quite a simple question for you, which I'm going to hopefully put up just now, is, and hopefully you can see the poll open. So the question is, which emerging applications represent the largest opportunity for gas engines? And the four options are the options which Silvestros presented during the webinar. So flexible generation, microgrids/hybrids, diesel replacement, or data centers. So the poll is open, and I can see that some people are responding already. So we'll give you another 15 or 20 seconds to submit your responses. So I think 75% of people have voted so far. 80% of people have now voted so far. So I'll give you another 10 seconds to submit your final results before we close the poll and publish the results. We'll publish the results immediately so you can see the responses from everyone else on the webinar. So I think, see, there's 1 or 2 people still to vote. I'll give you 5 more seconds.
It's a tough decision.
You've only got to make one choice. Okay, I think we're just about there. So let me close the poll. And now we can share the poll results with everybody there. So I think you can all see hopefully you should all be able to see the results now. So a fairly clear winner with flexible generation, peaking power taking over half of the votes, closely followed, well, not really closely followed, but in second place, microgrids and hybrids. The same for diesel replacement, 17%, and then finally data centers. And I think that result is not so surprising, actually. I mean, flexible generation, the clear winner. I think we probably would have predicted that before the webinar. We've seen in the UK, for example, the introduction of the capacity market and providing flexible generation services to the grid has resulted in a big uptake in gas engine sales in recent years. Likewise, in Germany, for example, policies are reforming to incentivize CHP plants that can operate much more flexibly. So already we're seeing developments which are promoting the use of gas engines within that flexible generation or peaking power application. So thank you very much for taking part. So finally, we'll just come on to the final part of the webinar, which is the Q&A. So we have seen over the course of the webinar lots of questions come in, so thank you very much for those. I think we've got a few minutes at the end just to take a couple of questions. So let's just have a look at which ones, Dina, you're looking through right now. I think, what question have you brought out?
Let's try this one. Does increased penetration of intermittent renewables always lead to a complementary role for gas? Well, not necessarily. It's one of those it will depend kind of questions. So it'll depend on a range of variables, the country or the region. So, one of the earliest slides, Silvestros indicated, it depends on the other sort of flexible options available. And this will differ per country. So, there could be interconnectors, there could be flexible hydro, there could be existing flexible centralized gas, flexible decentralized gas plants, storage, EVs, demand response. It depends, we could use all of this. Now, if there are existing forms of flexible solutions in this country or region or wherever it is, this may potentially require new market mechanisms, such as a capacity market, to pay for them to be there. So, this exists there. Then it's not only about today, but, going forward, the levelized cost of energy, is it cheaper for gas? Will regulations in the future tilt the playing fields towards particular solutions? Is there plans to expand the gas? What is the supply? It really will depend. So if I think about, say, Denmark and Spain, they have quite a high share of not only renewables, but intermittent renewables, so solar and wind. But their gas demand hasn't increased by very much. You would think, okay, something must be countering the inflexibility of solar and wind. And that's because, for example, Denmark sits between the Nordics and Western Europe. So it has robust transmission links on either side, and it can export or import electricity freely to make up excesses or shortfalls. Spain, previously had the economic recession, so maybe demand was stagnated there. But the bulk of Spain's wind balancing capacity has never come from gas, but from hydro reserves. If I think of India, for example, they've included in that stranded asset risk. So there's tons of coal power, so they've decided to make the coal power plants more flexible to counter this. So, really, it's not about simply doing a global scan of where renewables are increasing, and then that's definitely going to be where gas can play a role. You have to think carefully about which application and where and even when your gas-based products stand a chance. So I hope that kind of answers your question. It's one of those difficult ones, yeah.
Well, thanks for that, Dina. That's a pretty thorough response to that question. I mean, we've had a lot more questions come in actually, and we're definitely not going to have time to answer them all. So what we will do is take these offline and respond by email or by phone afterwards. But thanks very much for those questions. We've maybe got time for one more or two more. There's one that's come in which is asking about whether we're aware of any current or future regulations that will make diesel engines undesirable within standby power markets. Well, we've already seen that, haven't we, in the UK, that there's been certain regulations come in regarding emission limits for NOx and SOx and things like that, which has essentially kind of pushed out diesel engines within the capacity market, for example. So when the capacity markets were first launched in the UK 4 or 5 years ago, there was a lot of diesel that came into those markets. But subsequent to that, the regulations have been changed, which have reduced the emission limits for generators that can play into the capacity market, for example, which wasn't specifically aimed at diesel gensets, but had the result of pushing out diesel gensets, which has resulted in the uptake of gas engines within the UK. The medium combustion plant directive and other European legislation is moving in that direction as well. And in Germany, there are developments to reduce emission limits, which again will likely make it a more favourable landscape for gas engines versus diesel gensets, essentially. So I think the general direction of travel is one where emission limits will be such that it will make gas engines more favourable in the future. So that's the short answer to that question. Any other ones? There's lots of questions here actually, which would require quite a long time to answer, I think, which don't require a quick response. I think the best thing to do for those ones is to come back then by email. There are some questions which relate to whether our reports look at LPG. I think the short answer is yes, we do look at LPG. I think the applications for LPG are niche and local to some countries which do not have clearly mature and wide natural gas networks. But of course, we've seen some projects which are using LPG and also CNG and things like that. Typically, actually, within smaller gas engines rather than the 400 kilowatts plus that we look at within the DPS. So I think we're out of time, unfortunately. Thanks very much to everyone for joining us for the webinar. Thank you very much for taking part in the poll and for your questions. Like I said at the start, the webinar has been recorded and will be available to watch back afterwards. If you require the slides, please do get in touch. We'll be happy to email them to you. And like I mentioned, for any questions that we didn't get a chance to answer, thank you for sending in so many questions, but there are just too many to answer right now. But we will come back to you over the next 1 or 2 days. So thank you very much and wishing you a very pleasant rest of the day.
Bye. Take care.
Bye.